Thank you for taking time off to join us at the webinar today. My name is Angeline, the Senior Market Developer, and I have my colleague Troy, who is the Senior Product Engineer, to speak about optimizing flexible film solutions for your sustainability journey. So today's value chain has become increasingly complex and especially demanding on solutions that ensure products are safely and efficiently protected along the way. So we will be sharing case studies on how ExxonMobil Performance Polyethylene can provide sustainable solutions to meet your value chain needs. I will begin with a brief overview of how ExxonMobil Chemical broadly participates in sustainability, followed by providing examples in a segment of agricultural films. And Troy will then cover even more specific examples and case studies in segments of heavy-duty sacks, coalition string, stretch film, and laminated flexible packaging. For the benefits of those who are not familiar with ExxonMobil, let me give you a quick overview. So as you can see from this slide, we're not just a chemical company, we also have operations in both the downstream and upstream. So we're a highly integrated chemical company with our own refineries and natural gas processing plants. So the complementary strength of each of the business allows us to maximize the value of molecules such as lubricants and polymers that we produce. And now looking at our manufacturing operations, as you can see here, we do have global presence, if not in North America, Europe, Middle East, as well as Asia Pacific. If you look closer to where we are in Asia Pacific, we also have technology centers set up in Bangalore and Shanghai to support our customers' development activities in region. So what have we been doing in the sustainability front? So we have a central sustainability organization set up for chemical company as well as fuels and lubricants to accelerate our sustainability initiatives. So on this slide, you can see 5 focus areas that we have. The first is converting waste to value. The second is innovating products with sustainability benefits like waste reduction and increasing recyclability. The third is mitigating greenhouse gas emissions across the value chain, which we focus on mitigating emissions and saving energy in our own operations. The fourth is building sustainability in our major facilities, such as reducing greenhouse gas emissions, waste generation, and water consumption. Last but not least, focusing on employees' passion, we help employees to understand sustainability principles so that we can contribute in our businesses as well as their own lives. And in today's session, we'll be sharing more on the first 2 sustainability focus areas, which are converting waste to value and innovating products with sustainability benefits. And now looking at segments, agriculture is one of the segments that we participate actively in. And with the continuous increase in global population, we need more food. But we also have limited resources, so we need to increase crop yield in order to fulfill the world's food demand. Our portfolio of performance polyethylene, namely Exceed, Exceed XP, and Enable, are widely adopted in agricultural films, which not only helps to increase land productivity, but also improve durability and reduce the risk of food wastage and spoilage across the value chain. Our performance polymers has also brought about great benefits in the flexible packaging segment. Because they are lightweight and also durable, they help to minimize food waste and lower life cycle impact due to the possibility of downgauging. We can use our performance polyethylene to also make coalition string, which help brand owners to realize cost savings by protecting or preventing the loss of goods during distribution. We'll be sharing more examples with you in the later part of this webinar. Now, earlier on, we've been sharing how our products, which are plastics, benefits the society, but also at the same time, we do share the society's concern about plastic waste. So globally, you can see it is estimated to have about 300 million tons of plastic waste generated, but only 14% is being collected for recycling. So we see a tremendous opportunity for us to play a significant role to address these concerns. But we cannot do this alone. We definitely need the industry to work together in improving the sustainability as well as circularity of plastics. So this is the reason why we are here today, to share some of the possible solutions we can work together on. We have identified a few dimensions that we can possibly work together. So one of them is designing recyclable solutions, where we strongly focus on developing monomaterial solutions, where we replace structures that contain substrates like PET and polyamide to enable recyclability. Next, we can also work on increasing recycled plastics content in your product. We know that mechanical recycling degrades the polymer with every cycle. So we leverage our high performance polyethylene to maintain critical properties of your product whilst incorporating mechanically recycled polymers. We can also look at down gauging with the use of higher performance resins, hence reducing the material use and cost, helping to achieve more with less. In an earlier slide, we've been talking about mechanical recycling helping to capture value from plastic waste, but we recognize that it has its own limitations. For example, performance loss, or it can be difficult to remove contaminants, which is critical for food and healthcare applications. So here we introduce advanced recycling, which involves the breaking down of plastic waste into its molecular building blocks. So this is then used as raw materials to make virgin-like plastics again. We believe that advanced recycling is a necessary complement to traditional mechanical recycling. So this is the reason why we ExxonMobil is investing on technology to help enable and accelerate large-scale advanced recycling solutions. And from here, we'll be going to bring in application-based case studies where ExxonMobil Performance Polyethylene contributes to sustainable flexible film solution. I will be conveying the agriculture segment, and Troy will take you through the secondary packaging and flexible food packaging segments. In the realm of agriculture space, we have been developing sustainable solutions for applications such as greenhouse films, mulch, silage, pond liners, and so on. So our solutions using our performance polyethylene has demonstrated that it is able to achieve up to 25% down gauging and yet still deliver durable films with excellent mechanical and optical properties. In this way, farmers will be able to spend their time on more productive activities rather than trying to manage broken down agricultural films. So in the next few slides, I'll be sharing with you more specific examples to illustrate what we mean. The first example I have for you here is on silo bags, which are used by farmers to store and protect grains. So the films are required to be very tough and durable. And on this slide, you can see we have two films examples. One is a market reference at 230 micron, and the other one is using Exit XP solution, which we have down gauged to 200 micron. So despite down gauging from 230 to 200 micron, our Exit XP solution is still able to demonstrate more than 60% higher impact and 20% higher puncture resistance. So this has brought about cost savings in the value chain with no compromise on the film performance, hence achieving doing more with less. The next example I have here for you is on greenhouse films. So greenhouse films are used by farmers to have a controlled environment for crop cultivation. This has helped them to achieve higher crop yield with all year round harvesting. So it is important to have a good mechanical and aging performance to ensure the crops are well protected. And over here we also have two examples. One is a market reference with at 200 micron, and the other example is using Exit XP solution, which we have down gauged 20% to 160 micron. Our Exit XP solution over here has demonstrated superior aging performance because even after 3,000 hours of accelerated aging test, we're still able to retain 83% of initial strength compared to the market reference at only 50%. So this has allowed the down-gauge greenhouse to be used for longer duration or potentially be reused again. And the last example I have here for you is on silage covers, which one of our customer has managed to incorporate up to 50% of recycled polyethylene into the silage cover, while still obtaining outstanding dust impact without having the need to upgauge. So film performance in this application is very critical because it is used to store food for livestock, and the underperformance of the film could mean losing the year's worth of feed for their animals. So this example has demonstrated the confidence our customer has in the performance of Exit XP by incorporating high level of recycling. And this is also a very good case to demonstrate the possibility of plastic circularity with our product, capturing the value from plastic waste. And now before I hand off the next part of the webinar to Troy, I would like to summarize the 3R sustainability objectives in agricultural films. The first is on reducing the amount of film we use through down gauging. The next is with higher performance resins, now films can be used for a longer duration and also potentially be reused for a second time. Lastly, incorporating recycled plastics without compromising in film performance and maximizing cost benefits. And with that, I'll hand off the next part of the webinar to Troy. Troy, over to you. Thank you.
Thank you, Angeline, and good morning and good afternoon to all those who have dialed into this webinar. My name is Troy, and in this section I'm going to discuss how we can create sustainable solutions in some important secondary packaging applications. I will cover 3 applications: heavy-duty sacks for palletized goods, shrink films for bundling of food and beverage products, and stretch wrap films. Let's first look at heavy-duty sacks. As an example, one of the more common applications of heavy-duty sacks is the packaging of polymers, as you can see in this picture. This is an application that we know very well at ExxonMobil, as much of our resins we ship to customers worldwide are contained in this form of packaging. With advances in extrusion and packaging technology, in combination with the use of high-performance resins such as those from Exceed Enable and Exceed XP portfolio, thinner, heavy-duty sacks can now be made which deliver excellent toughness and bag drop performance, excellent creep resistance, and the necessary sealing characteristics for high-speed packing line operations. This is a great example of the reduce concept. But the bulk of heavy-duty sacks made today is still the domain of virgin resins. Let's now look at the potential of using recycled resins to produce high-performance heavy-duty sacks. 2 other key sustainability concepts we hear a lot about when it comes to managing plastic usage and waste are reuse and recycle. The concept of multi-cycle recycling advances this one step further. In collaboration with Reifenhauser and KZPM, EM produces a series of films to assess the performance of heavy-duty sacks containing recyclate that had undergone up to 4 extrusion cycles. In this development, Reifenhauser also applied a tracking technology to monitor materials throughout the cycles. Initially, a 5-layer high-performance heavy-duty sack film was made using virgin high-performance polyethylene resins from ExxonMobil. These bags were pigmented white and they were also printed. The first recyclate was produced by shredding and pelletizing this material, and then a second heavy-duty sack film was made by incorporating 30% of this recyclate with virgin resins. And so the process repeated itself 2 more times, each time using 37% recyclate from the previous extrusion cycle. Unfortunately, we have not included the video clip today showing you the recycled heavy-duty sack films in operation, as we are concerned with potential poor video quality from a live stream with such a large number of participants dialing in. But we have included the video clip in the recorded version of this webinar, and I encourage you to watch it. Nonetheless, I can report that the results are impressive. Apart from exhibiting excellent film appearance and processability, the recycled heavy-duty sack film was also shown to have similar stiffness, toughness and sealing performance, as well as the ability to pass stringent bag filling and bag drop tests, all at the same gauge as the virgin formulation. Hopefully, you can now appreciate the potential of high-level incorporation of multi-cycle recyclate into heavy-duty sacks. In this case, we have demonstrated 37% incorporation. The key elements in this case being the use of high-performance polyethylene resins, such as ExxonMobil's Exceed Enable and Exceed XP, the use of high quality co-extrusion equipment, particularly 5-layer lines, and the use of high quality recyclate. Now let's discuss an application that we regularly encounter in our everyday lives, collation shrink film. Besides being a lightweight, waterproof and cost-effective packaging, attractively printed collation shrink film also draws consumers to the product. Let's discuss how we can make collation shrink packaging more sustainable while still ensuring all key properties are maintained. The two sustainability concepts we will look at now are recycle and reduce. As I showed in the heavy-duty sack example, using a combination of high-performance ExxonMobil polyethylene resins with high-quality PCR is key to achieving high levels of PCR incorporation. PCR, of course, meaning post-consumer recycle. In collation shrink, the story is similar, with even 50% PCR content being achievable. Not surprisingly, the use of higher quality PCRs are better able to confer acceptable end-use performance attributes at higher incorporation. For collation shrink, the key attributes include stiffness and toughness, shrinkability and holding force, and good film appearance, such as good optics and low gel levels. Higher quality PCRs would typically be sourced from clean, controlled streams. But as long as the PCR is cost effective at meeting the end-use performance and relevant regulatory requirements are met, a variety of PCRs can be used. Whilst the price of PCRs vary due to quality and availability, we have seen the positive effect of extended producer responsibility schemes that can incentivize and monetize the use of recycled resins, potentially making recycled solutions cost competitive versus virgin plastic formulations. Now let's take a look at down gauging. Consider a 40 micron reference film made from commodity resins including LDPE. Using a high-performance ExxonMobil resin solution, we can down gauge by 25% to 30 microns and still deliver good stiffness and toughness, adequate shrinkability and holding force, excellent gloss for enhanced printing aesthetics, and cost savings. And now we come to stretch wrap. As we all know, stretch wraps are used extensively to contain a wide variety of goods. On the surface, stretch wraps might appear to be quite simple and unsophisticated, but their structures are actually many and varied, and they can be tailored to meet specific needs. Let's look briefly at the manual variety, commonly referred to as hand wrap. The choice of hand wrap is determined by a combination of many factors, including its ease of use for the operator, the desired level of holding force to secure the load, the desired level of puncture and tear resistance of the stretch film, and the cost of the film, which takes into account the upfront cost of the film roll itself and the number of wraps that need to be applied. But what if you could use a hand wrap that gives similar or better performance at thinner gauge with fewer wraps to reduce cost and waste? Well, using ExxonMobil performance polyethylene resin solutions, this can be achieved with our high tenacity and easy stretch high performance hand wrap solutions. Let's now look a little bit deeper into the importance of load security. This image depicts a scene all of us have observed many times before. The delivery of goods by road transportation, often across long distances. We make the assumption that all palletized goods in the trailer section are properly stabilized and secured during transportation, that the vehicle arrives safely and timely at its intended destination, and on arrival, all the goods are retrieved intact and in the same condition as they were when they were loaded. Unfortunately, this is not always the case. If we just look at statistics for Europe alone, about 4% of goods don't even reach their destination, and worse still, more than 1,000 lives are lost each year due to mishaps and accidents that occur during the journey. Inadequate load security is a major contributing factor. Let's look at two video clips that simulate how a stretch wrap pallet in the trailer of a truck might respond to sudden acceleration and deceleration. In each case, an 8-micron stretch wrap has been used. The top video shows a market reference film, and the bottom one employs a high-performance ExxonMobil solution. For the market reference film, you can see that the holding force is inadequate, resulting in the goods becoming loose and even breaking from the stack. In an actual situation, this would potentially create a significant containment problem and/or damage to the goods, as well as creating a potentially serious safety incident when opening the trailer and offloading the goods. With the ExxonMobil formulated solution, you can see that it provides a stronger film with much improved holding force. This translates to reduced cargo damage and wastage, lower transportation packaging costs, and reduced tendency for a significant safety incident from a loss of containment. In another example, we were able to replace an 18-micron commodity solution with a 12-micron high-tenacity ExxonMobil solution to reduce the weight of the film applied on the pellet by 40%. With the same number of wraps, the ExxonMobil solution is able to reach the same or even higher load stability than the commodity-based market reference. In addition, with each roll of thinner film, more pallets can be wrapped for a given roll weight. In this specific case, we calculated the value creation to be more than $1 million per year for a 2,500 ton per year business. In this calculation, we didn't even take the saving on reduced goods waste into account. Another great example of sustainability benefits. So I'd like you to take away two key messages from these stretch wrap examples. The first one being the importance of optimizing load stability and its impact on reducing loss and containment with fewer safety accidents. And the second point is the significant benefits that you can realize from using down-gauged high-quality stretch wraps like those formulated with ExxonMobil Performance polyethylene resins. Performance improvements such as improved holding force and puncture resistance, cost savings from using thinner films, potentially less wraps, and producing less damaged goods. With continued understanding and implementation of these concepts across the supply chain, we can all enjoy these sustainability benefits. And that concludes my talk on industrial packaging. In this final segment, we will be highlighting the sustainability effort ExxonMobil Chemical has made in flexible food packaging. Aligned with our central pillars of recycling design and lower cost sources and achieving high performance, ExxonMobil continues to develop innovative solutions with our value chain partners. With regard to food packaging, one of the missing pieces in the puzzle is the mechanical incorporation of recycling due to the sensitivity of the recycle stream in food contact applications. It will require a consolidated effort from the whole value chain and regulators to understand and implement workable guidelines with respect to recycle type and content in food packaging. Beyond the benefits of flexible packaging, ExxonMobil shares society's concerns about plastic waste in the environment and agrees it must be addressed. ExxonMobil is taking action to address plastic waste in the environment by increasing plastic recyclability, supporting improvements in plastic waste recovery. For example, through our founding membership in the Alliance to End Plastic Waste, and minimizing plastic pellet loss from our own operations. It is technically and economically challenging to mechanically recycle products comprised of multiple types of plastic, such as in multi-layer packaging, and plastics also contaminated with food waste. The development of mono-material solutions in food packaging will support the effort in building up and improving waste collection infrastructure to boost the recycle rate in our society for flexible packaging. So why don't we recycle more of our flexible packaging today? The simple but boring answer is that recycle is not that easy. Waste streams are diverse, potentially polluted by external contaminants, with sometimes incompatible materials like multi-layer packaging. Sorting and handling are critical to maintain consistency, which can make recycled streams costly and supply limited. Crucially, the mechanical properties of recycled polyethylene are often not as good as virgin polymers. Multi-material laminates with polyethylene sealant layers can include one or more non-polyethylene substrates. Some of these include foil and metallized films to provide gas and light barrier, and sometimes the polyethylene sealant layer might contain barrier resins. Developing monomaterial solutions for these particular examples is obviously quite challenging, and viable solutions continue to be worked on. But for today's discussion, let's consider the multi-material laminate depicted in this slide, which is still commonly used in many food packaging applications. The substrates considered here are either polyester or polypropylene or polyamide, as they provide good print register due to their stiffness, good heat resistance to prevent them from melting during sealing, and in the case of polyamides, added toughness and some gas barrier improvement. Replacing these substrates with a coex polyethylene structure to produce a monomaterial, fully recyclable solution is indeed achievable. In developing a full polyethylene solution, a robust design is obviously needed to ensure food preservation, especially given the contents of the packaging has a much higher value. In this particular case study, we developed a PE-PE laminate based on ExxonMobil Performance polyethylene resins and machine direction orientation technology with the support of our partner Hosokawa Alpine. These laminates were used to produce stand-up pouches just like the one you see in this picture. The result, no compromise in packaging integrity, nor stiffness, nor shelf appeal. The PE-PE laminates used to make the stand-up pouches were derived from films made using ExxonMobil Performance polyethylene resins on Hosokawa Alpine's 5-layer blown film line. For a given formulation, rigorous bag drop tests were carried out using water-filled pouches. The drop test was calculated as a percentage of the pouches that showed no signs of leaking or breaking. We were able to achieve up to 100% pass rate. Now that we had developed a workable monomaterial stand-up pouch, the next step was to investigate recycling potential and recycle incorporation. With the help of one of our partners, Henkel, a solvent specifically designed for the mechanical recycling process was applied, which helped maintain the performance of the recycled material. We also partnered with Arema, who helped process the used stand-up pouches back into raw material form. With 30% of this polyethylene recyclate added to 70% of virgin ExxonMobil Performance polyethylene resins, we were able to produce stand-up pouches just like the one you see in this picture, with little loss in performance and appeal. So together with the help of our value chain partners, we have shown that it is possible to make workable monomaterial laminates with up to 30% high quality recyclate. Granted, there's still a lot more to do in this space, but we're now one step closer in achieving our goal of a circular economy. As mentioned earlier, ExxonMobil continues to work with industry partners to provide additional functionalities needed in some flexible packaging applications that would otherwise be provided by other more difficult to recycle materials. Finally, let's just look back over the last 25 years or so and consider the huge impact that the introduction of new and improved performance grades of polyethylene to the marketplace have made at reducing flexible packaging usage, along with advances in extrusion and converting technology. The result, up to 35% less plastic usage for those applications, thinner films with improved performance, more efficient and more robust packaging designs, reduced packaging and logistics costs, a reduced carbon footprint. So in closing, let's just be reminded of how critical plastics are to everyday life. With the cooperation and commitment of all parts of the supply chain, with advances in recycling technologies and waste collection, the plastics industry needn't be viewed as the bad boy, but rather part of the solution for a sustainable future. Hopefully, ExxonMobil Performance polyethylene resins will feature in your sustainability journey too.